I think I'm going to talk to you a little bit about the importance of, or make the case for the life course approach to cognitive aging and dementia, talk to you a little bit about our results, and then start a conversation on dementia. I mean, there are loads of questions, and I think what we're trying to do is to ask the causal question as to what are the real risk factors. If you change them, would you change the dementia outcome? So I'm going to show you some results. All right, we know that the numbers of people living with dementia is increasing, and it's mostly because of increasing life expectancy. The incidence rate might be falling. I mean, there are now studies from across several sites in Europe which show a small fall in, and Framingham, where there is a small fall in the incidence rate. But the numbers of people living with dementia will continue to increase because of increases in life expectancy. Now, the interesting idea is that if we separate Alzheimer's disease and dementia, I mean, Alzheimer's disease being one of the causes of dementia, dementia being something where you have clinical symptoms of Alzheimer's disease, 1 year delay in dementia will lead to smaller numbers. So there is some scope of thinking about dementia in terms of prevention. We also know that the failure rate of drugs is 100%. They couldn't have done better. We also know now that a lot of the multi-domain trials, that are based on physical activity and video games and eating nuts and seeds, they've all failed. I'm going to try and give you my point of view and why that is the case. Just sort of, this idea of looking at brain structure and function. There is this tremendous focus on trying to scan the brain even better. To understand dementia, for me, it doesn't make sense, because if there was a tight relationship between brain structure and function, this is what you'd get. You'd get a nice, inverse association between the two. But real life looks like that. So these are the stages of dementia. They're called Braak stages, based on examination of the brain, that being the most severe. And these are MMSE scores taken 1 year before death. So you see that this relationship is far from linear and far from this tight relationship that you would observe. So what you see in the brain tells you quite a bit about cognitive function, but it doesn't tell you everything about cognitive function. Now, a lot of the studies on aging and dementia, one of the problems is that if you look at this from a life course approach, you see that a lot of the studies, that's the age at baseline. Most of them are based on older folk. I understand why. You recruit into a study, you wait for sufficient number of events to occur, and then you run your Cox regression. That's one of the reasons why these studies have been done. But what if the disease started much before you recruited people into your study? And that's the question we're asking ourselves. I mean, I'm not the only one asking myself that question, because you see most of the studies that want to look at aging now recruit way earlier. So these are here's in the UK, that's the French large study, and that's the German one. They all have, they're all recruiting earlier. What has been done previously is that although we accept that, cognition, there must be a period of a life where there's cognitive development, some sort of stability, small decline, and then this rapid decline. Most of the aging studies observe this period. So as I said, it allows you to run Cox regression, where you have your reference group, people who do not have dementia, and then you try and compare them to people who have dementia and disability. It's the same process. And you get odd results. The idea of looking at it from a life course perspective, it might have relevance for plasticity. We know that there's tremendous plasticity at younger ages. We've seen this with the Flynn effect, which is the increase in cognitive performance in the younger cohorts. There might be ways of delaying decline here, not here. There might be ways of modifying the rate of decline and then identifying risk factors that are not biased by reverse causation. This is the Whitehall 2 study. I'm not going to tell you a lot more about it, but that's the nice bit about the study is that cognitive function was measured starting in 1997 when people were 45 to 69 years old, and we've got cognition across. I mean, if you can arrange your data and if you know a little bit about longitudinal modeling, we cover the age spectrum from 45 to 86, and we are going to be collecting data again soon. So we're sort of getting the procedures in place. We've got the funding. So, and then there are sub-studies, and you'll have the slides, so you can look at the kind of measures we have. Looking at how this is our approach to cognitive aging and dementia. So we're studying both. We want to look at the heterogeneity in cognitive decline starting at age 45 and how this relates to dementia while taking into account mortality, the competing cause of, the competing risk of mortality. Now, one of the things, this is an early paper, when we started looking at cognition, there was Trey Hayden had published this review in 2004, and his conclusion was that there was no cognitive decline before the age of 60, and that's what people thought was true, simply because there were no data. I mean, most of this is based on small bits of data, the Seattle longitudinal study, small numbers throughout. We looked at this with larger numbers. As you see, each of these groups has larger numbers, and there's a nice, as you'd expect, there is cognitive decline in everyone included in the study. There was cognitive decline across the board. So then that got us thinking about how do we understand this cognitive decline? What are the determinants of this decline? And I'll show you some results. This is smoking. So where we looked at smoking status and cognitive decline. Now, what was interesting here isn't you would expect the smokers to have faster cognitive decline. But what was interesting here is that the long-term smokers, these are people who had given up smoking for over 10 years, there was no residual effect of smoking. So from a public health perspective, there is this whole idea of promoting smoking cessation even in midlife. And then trying to model, trying to take into account mortality, because smokers also die. So if you were to plug that in using something called joint models, you see that the effect of smoking is larger. And then we've looked at cardiovascular risk factors. This is not cardiovascular disease. These are Framingham risk scores, a series of papers looking at Framingham risk scores, so cardiovascular risk and cognitive decline. And as expected, we found effects. Now, this is a recent paper where we looked at atrial fibrillation. So atrial fibrillation becomes common at older ages, and it is associated with dementia. But at older ages, you don't know what comes first, whether you've people who have dementia then get atrial fibrillation or how this happens. So we looked at cognitive decline. And in the modeling, so we're looking at people who have atrial fibrillation between 50 and 65. So you've got 3 segments. Because the baseline age is 20 years, we can run these analyses. And what the line in gray is the cognitive decline, which we'd seen previously in people without atrial fibrillation. And the colored blocks show significantly greater cognitive decline in people with atrial fibrillation, irrespective of age. So that's a nice way of showing that something like atrial fibrillation matters for cognitive decline. Now we come to difficult questions on dementia, and these are questions that remain debated, and I don't have answers. I'll just tell you our point of view. It's now sort of widely accepted that when in people with clinical dementia, so they have clinical symptoms of dementia, there are changes in various biomarkers. This is called the Jack model, model put together by Clifford Jack and various other colleagues. You can see that this model proposes is that there are a range of changes in various biomarkers to do with amyloid and tau pathology. And this can be detected 15 to 20 years before clinical diagnosis of dementia. So if you accept that model, so if someone with 80 has a diagnosis of dementia, this implies that at age 60 there were already changes in various biomarkers. So if we think about the risk factors or causes, we need to, and this idea of temporality. So we ought to be looking at risk and protective factors way before we see these changes. So that's what we've been trying to do. It goes back to what I said to you in the beginning, that most aging studies focus on people who are 65 and plus. Now, in Whitehall, we've got electronic linkage to our data on dementia. So we've got cognitive function that we measure at the clinical examination, but our data on dementia comes from linkage to electronic health records. We use HES and the mental health records. So when we started research on dementia, and this is new, all the work that I'm going to show, it's happened in the past couple of years or so. One of the things that we wanted to look at was whether the measures that we have of dementia, are they comparable to what you'd see in a study that does proper assessment of dementia, with MRI and seeing a neurologist. So this is the Packwood study, which had published this paper in 2008. So that's the year of dementia diagnosis, and people in red are dementia cases. The red line represents dementia cases, and these are the non-demented individuals. What they showed is that so if you go backward, because this study also has measures of cognitive function, if you go backward, you see differences in cognitive performance showing up 10 years before diagnosis. So this is it's a widely cited, nice paper. We show the same. These are our dementia cases using electronic health records. So it's not the same quality of data because we're missing milder cases, but you see a similar pattern. So these are results that we've used to say that, okay, our measures of dementia might not be great, but they're not so bad. Now, there was this paper published in Lancet Neurology by Kizilbash and colleagues in 2015 maybe, or I don't know if you remember, 2015. And they used, again, data on GP records on 2 million people to show that obesity had a protective effect. So lower risk of dementia in the obese. So we wanted to look at that, but the follow-up in that study was 10 years. So here are Whitehall cases of dementia in red. These are the non-demented individuals. And if you go back in time, what you see is that if you go back 28 years, people who developed dementia had higher BMI, as you'd expect them to be. So if you look at this, if you did a Cox model and just sort of modeled time, you'd see this. So BMI in midlife is a risk factor for dementia. But what happens is that people who get dementia lose interest in food, forget to eat, and you see a decline in their BMI. So in short follow-ups, you're going to get this odd results. The next another way of looking at the same thing is to look at obesity at age 50. There again, you can get into the data, because we have data over 30 years. You can get into the data, extract BMI at age 50 from across the weight. So for every individual, we have data on BMI at age 50, at age 60, and at age 70. There you see, this is a standard Cox model. BMI, obesity at age 50 is a risk factor for dementia. I'm going to talk to you about reverse causation. There are there's a lot of, there are loads of papers that show that physical activity might have a protective effect, and depression might be a risk factor. But again, these studies have a short follow-up, and you don't know whether this is a causal risk factor or if it's the preclinical phase of dementia that's affecting your risk factor levels. These questions are important because you see, based on the observational data, these studies obtained quite a lot of funding to run large, these are large multimodal interventions on, I don't have numbers, but these are not based on hundreds of people. There are thousands of people in there, they're long term. Both of them failed. So there's no effect of physical activity in intervention studies on cognitive decline. There is on depressive symptoms, there is an association if your follow-up is short, but not if your follow-up is longer. So we've sort of looked at this, and I'll show you. So this is physical activity. In red again are cases, dementia cases. So you see this decline in physical activity in the 10, 12 years before dementia diagnosis. But if you go all the way back, this is 28 to 12 years before dementia diagnosis, the level of physical activity between those who develop dementia and those who don't is no different. And then again, we checked it with Cox model, and there is no effect in midlife. The same with depression, but here you have, I think the yellow case are dementia cases in yellow. There is an increase in depressive symptoms in the preclinical phase of dementia. So looking at this, trying to change or modify depressive symptoms isn't going to have any effect on dementia outcomes. So I think the questions we're asking ourselves, what are the risk factors? If you look at this from a life course perspective, how do you handle this whole idea of age of exposure? We didn't get to talk about threshold of risk, but with blood pressure, we show risk at thresholds below the threshold used for cardiovascular disease. And what do we do from a prevention perspective? And I think we've got to recognize that drug trials have failed. We've got to figure out how risk factors work together, and when does prevention begin? This is the group in Whitehall and the group in Paris. Thank you very much.